So after our students have completed drawing their predictive models and they've chosen their landforms and they've made predictions of how the water is going to interact with the land, the next step is for them to actually do an investigation. So they would have to build their physical models of their landforms, and they're actually going to test how the water interacts with them. So before your class gets to that step, you want to set up your stream tables ahead of time. You want to make sure that you think about the setup of your class. You want to think about the dynamics, how many students you're going to want to have per group. You want to have ample space for them to be able to actually create their landforms and do their investigations. You want to make sure that our sand is actually damp before they begin, unless they're making a dune or something. Everything else needs to be damp so it's actually pliable so they can actually build with it. And the key component is to make sure you have something there to catch the excess water on the bottom. So that's pretty basic for a stream table setup. If you wanted to create the meandering river or something, you could put a ruler here and put the cup on top, or you could just hold it and then you can have them slowly pour. Just a couple quick tips for your stream tables. So let's move on to making our physical models. Can we have all of our groups come over to a stream table and make sure you bring your model with you? So just looking at the models that we created, how can we actually figure out how the water is going to interact with the land? What types of things can we do to actually figure that out? Talk to your partner for a few seconds. Okay, so it sounds like you all have a pretty good idea of what you can do to investigate. Did anybody want to share what their ideas are about how they can actually test their theories?
So our group, we're going to use the dry sand to build our sand dune. We're not going to add any elevation, but we are going to use the holes in the cup to hold it directly, and hold our cup directly over our sand dune, the peak of the sand dune, to simulate rain and see how that affects our sand.
Okay, so I think what I hear you say is that you all are going to test the rain component of water interacting with the land. That's a great idea. How about this group? What are you guys going to do?
So we talked about how we have meander. So we were just going to take our finger and trace the path that we made on our model, and then we were going to use water over top, not as rain, but actually as a source for the river, to see what the river source water will do to the meandering river.
Okay, I like that idea. In this last group?
So we were thinking about building the gully and actually propping the stream table up a little bit, because the way it looks like the way our gully is now, that the water's flowing in one direction, so we wanted to make sure that there was more of a flow, so we needed an angle for that.
Okay, so that was a very good point. If you all wanted to add a slope component to your models, you could do it one of two ways. You could either have one of your teammates just kind of prop it up while you do the investigation. You could use books or blocks, anything you have accessible in your classroom that will hold it up. And then you may figure out that you want it at different angles of a slope while you're experimenting or investigating. So what we're going to do now is we're going to actually build our models. Thank you. I'm going to get those out. Here you go. They can use, it's more lids in there. Yep, on the bottom. Oh, good.
Okay.
Wanting to make it bigger than it is on the picture here.
So, I have a question for your group. If you all are creating a meandering river, do you think that slope might be beneficial for that?
See, it's interesting because when you talked about over there, when that group talked about they were going to take their stream table and prop it up, that made sense for us too, because it's not rain that we're testing.
Oh, okay.
It's the source of the river.
And we did talk about that we thought our water was, we drew arrows, that our water is flowing in this downward direction, so it would make sense for us to design something that's showing it flowing.
Perfect.
So it's not just sitting.
Perfect. I love it. Okay, teachers, so just a few things to think about while you all are finishing your results piece. Logistically and setup-wise, there were a few things that came up when we actually created our models. So just a couple tips to think about when you're doing this with your class. You may want to keep extra water, because a couple of my groups actually came up with new questions, which is what we push our kids to do, come up with new questions for their model. So they wanted to test their water a different way. I had another group who wanted, they didn't want to use the rain as a means of getting water into the land. They wanted just a single source, so we kind of had to improvise and just use the bottle. But you may want to think about things like that. So we had our holes in our cups already set up for everyone to use rain, but our students have all these amazing ideas and they're going to want to do it in different ways. So we may want to be prepared to have a setup for students to come up with their own investigations to figure out how they want to do it, because after all, that is our PE, right? They have to come up with an investigation and conduct it on their own. So we want to make sure we have everything available for them to do that.